Hello, I'm Jinju. Today we will walk through the part 2 of version 3, which is slicing the data with rows and columns. Now, let's go back to the image CSV data. Let's move our mouse to the top left of the data we want to slicing down. So here, I hope this still looks easy. This is part we want to slicing down. And now we need to use the row numbers and the column numbers to determine this rectangle. From here, we can see, let me zoom in more. The from row number is 22 and the to row number is 41. Let's keep that in our code. So in our code, let's right click, new file, and slice image with row and column.py. In this image, in this Python file, because we need to read CSV, so we need import pandas as PD. Because we also need to slicing using the row and column way, so we need to import NumPy. And let's run this too. First, we will get the from, to, row, and column indices from the CSV file. Row from and row to equals, let me go back and check again, 22 and 41. Okay, 22 and 41. And the row and the column from and the column to, which is, let me check here, it's row 7 to column 7 to column 40. Okay, not sure if you can see this, but hope I can make it a little bigger. 7 to 40. Let's keep this and 40. All right, let's run this. Now we know the row from, row to, column from, and column to are this. So here we can read the CSV file. So image df equals pd.read CSV. We know it's this CSV, so we can copy the relative path and paste it there. Again, we because we know that the first row is column, so we in this time we need to remove header equals now. Okay, let's execute this. PD is not defined. Fair enough. We'll not run these two lines. And then we read image.df. Okay, Now we can see we have read 92 by 154 of the data arrays. Now we need to use this row column information to slicing down the rectangle we need. Before really using this row and column information, I will make a simple example of how to use row column indices to slice down an array. So let's create a toy array, numpy.random.randint. We have 3 arguments. The first argument is low, meaning we want randomly creating some values. The lowest value is 0, and the high value, let's give it a 10. And the third argument is the size. Let's give it a size of 5 by 5. Okay, let's run this line. Now we will have a toy array. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. and we can check its shape, which is 5 by 5. Well, of course, because we specified as 5 by 5. Now, if we want to slicing down this part, what should we do? Let's see how we can slicing down that. So toy array, the thing I want to say is that NumPy array is row major order, meaning that when we try to slicing down everything, we need to starting from the row first. Let me remove all of this, you will understand. I will use a comma to split those row and columns. So the first part, this will be rows. The second part will be columns. We know it's the second to the third row, the second, third, and the fourth. So we need to somehow let NumPy knows that we want the 2, 3, 4 columns and the 2, 3, 4 columns as well. Sorry, this is rows. But in Python, the indexing starting from 0. That means this is the 0 rows. This is the first rows. Okay, this might be confusing, but we just need to know. Python started from 0. So this is the first row, and this is the fourth row. We use the comma to indicating that this is between 1 and 4. 1, 2, 0, 1, 2, 3. 1 and 3. Same story for the columns. It's the first column until to the third column. Let's see if that's right. That's not right. Could you say? We want 5, 8, and 5. Looks like we are missing the last columns and the last row. Why? Because in Python, the common slicing is only include. Let me get it here. Column slicing include the starting index, but exclude the ending indexing. That means even though we said we want the third row, but this row is ignored, we need to add one more. Now let's see. Now the result is correct. We can see we get the desired result we want. Okay, now since we know all of this bit of knowledge, I will comment them out. We need to slicing this array by this row and column indexing. So the correct way to do this is imagedf.ilog. ilog means indexing location-based slicing. The same story. We want, because it's row-based, we need to tell Python we want row from to row 2 plus 1, comma, and column from to column 2 plus 1. So by executing this command, we finally get all the information we need. How to prove this is the information we need? We can save the sliced data frame to raster. Before that, now we need to give it a name, so it will be sliced df. Okay, so we use sliced df to store the sliced array. The first thing we need to do is this is an array. Remember that GeoTIFF only needs numbers and the metadata. So what we need to do is to get array, sliced array equals to sliced df to numpy. Okay, so now we got all the numbers we need. After that, we need to get the sliced meta, which is a dictionary recording the drivers, the counts, the dtype, and everything. Out of all this metadata, we need to pay attention to these two. We need to understand we need to know what is the coordinate referencing system and what is the transform. For the CRS, let's go back to QGIS. Here we opened the raw data. We know that it's EPSG 38757, so we can simply make it here. Let's check again. All right, CRS, we are confident it is correct. The real problem is this transform. How could we know what is the top left corner of the sliced array? But luckily we can calculate this with the former metadata. So let's go back to the first Python file and run everything from there. So now we can print the original transform here. Let's copy it. Say meta before slicing, which is all this. So we can copy this 100 back to here. The first number indicating the x-axis, the width of each cell. We know that after slicing the data, the cell size doesn't change. The next number is always 0. If you want to know more about what the second number is controlling, you can Google this. And the third number, which is the x. The third number is the x of the top left corner. We know that we have sliced call2 minus call from. We have slicing just this many pixels, and each pixel is 100 meters. So that's it. That's what it should be now. And the same story for the fourth value, which is 0, and for the fifth, which is negative 100. Also, if you want to know why this is negative, you can just Google search the affine transform for GeoTIFF, and the same story for the x, which is the column number. We have slicing down column from minus column 2. We have slicing down so many columns, and each column is 100 meters. So now let's run this part of information. We get the correct transformation now. Okay, now we have numbers and we have geospatial information. We can use with rasterio.open data solar panel sliced.tiff and dst.write sliced array. Now we see these curly warnings. That means we are not importing rasterio now. So we import rasterio, run it, and run this line. Okay, now let's go back to QGIS and let's open up this panel sliced GeoTIFF, see if it works. Well, this is not working because we can see this solar panel sliced is not overlaying with, it's supposed to be here, but it's not. And I'm going back to the code and I found, yeah, we need to add this number here. I think that's right. Let's redo everything again, see if it works. Let's rerun all of this and save it again and go back to QGIS and drag and throw it here. Well, it's still not overlapping. This gray patch is supposed to be here. Okay, I understand why. Back to the code. The third number indicating the columns of the transform, we want to get this number. And we know, comparing to the original here, it is moving rightward by this much. Moving right is increasing is increasing, and same story applies. Comparing to the original row number, we are moving down, and moving down is decreasing the number. So let's put it there because we are moving right, so it's increasing these many cells. Each cell has 100 meter size. Same story. We are moving from, this is the original row. We are moving downwards. Downward is decreasing. So we are decreasing by this many number of rows. And then when we go back to the QGIS or overlay the new result, we can see, we successfully sliced down this part. Okay, this is the part of session 3. For session 3, we get the row number and the column number of the desired rectangle, and then we applied a slicing technique telling Python the row from and the row to and column from and the column to, and then we get this, we sliced down this rectangle. After that, we have saved back the rectangle to a GeoTIFF. During the process, we understand the transform, aka the original points, the top left corner is the most important part for a GeoTIFF file. And it took a bit of calculation to get to the number. Okay, this is the session 3, part 2.